Let's practice solving some one-step equations that have multiplication and division for the operations. So for questions 1 through 4, let's go ahead and determine the solution for each of the given equations. And we're going to be given a solution set. So basically, we're going to be looking for the correct solution or the correct number that makes the equation true out of a few different numbers that we are provided with. We're going to also make sure that we show some detailed and logical work that go ahead and supports our answer as well. So for question 1, we have this 0.7x is equal to 2.52, or you can also call this 7/10 multiplied by x is equal to 2 and 52 hundredths. So this really just means 7/10 multiplied by what number would equal this 2 and 52 hundredths. So let's try this 2 and 6/10 first. Let's go ahead and substitute that over here. If we go ahead and take this 2 and 6/10 and we multiply that by the 7/10, what are we going to get? Well, if you multiply this 2.6 by 0.7, it's going to get smaller because 0.7 is less than 1. So that's going to be 42. That's going to be 14 plus 4. That's going to be 18. So this is going to be 1.82. So that gets smaller, so that can't be the right answer here. So this 2.6 doesn't get us what we are looking for. What about this 3.2? Let's try 3.2 here. If we take 3.2 and we multiply that by 0.7, let's go ahead and give that a try. Well, 7 times 2 is 14, carry the 1. 3 times 7 is 21, plus 1 is 22. And we need 2 decimal places here, so 2.24. So that's still not quite what we're looking for, but we're getting closer. If we try 3.6 here, let's try this next value of 3.6 and substitute it in. If we take the 3.6 and then multiply that by 0.7, 7 times 6 is going to be 42, carry the 4. 7 times 3 is 21, plus 4 is going to be 25. So we're looking at 2.52. So this one does check out. So we know that 3.6 is the solution to this equation. So we can go ahead and say here that x would be equal to 3 and 6/10. That would be our solution. All right, let's check out a second one here. For number 2, we have this equation of y divided by 4 is equal to 2 and 48 hundredths. So I guess the question is which one of these numbers over here, if you divide it by 4, would get you 2 and 48 hundredths. Now, if you try this 0.62 or 62 hundredths and you divide that by 4, it's just going to get smaller, and that's not going to get us what we are looking for. We're trying to get a larger number, which is going to be 2.48 or 2 and 48 hundredths, right? Now, what if you take this 1 and 24 hundredths and you divide that by 4? Well, if you divide 1 and 24 hundredths by 4, it's also going to get smaller, and we're trying to get to 2 and 48 hundredths, so that's not what we're looking for either. What if we take this 4 and 96 hundredths and divide that by 4? That could potentially work, I guess, right? So we can go ahead and try this out. If we take this 4.96 and we divide this by 4, I don't think it's going to be quite what we're looking for, though. 4 goes into 4 one time, so it's going to be 1 point something. And notice how we're looking for 2 point something here, right? So that's not going to work either. So we know that it's not going to be 4.96, which then means that it has to be 9.92 as our answer. But let's go ahead and just confirm this real quick. So if we go ahead and take 9.92 and we divide this by 4, 4 goes into 9 2 times, so that makes sense for us because this 2 matches this 2. That's good. 2 times 4 is going to be 8, and if you subtract, we're left with 1. Bring down this 9 here. 4 into 19 is going to be 4. 4 times 4 is 16. We have a remainder of 3. And then we bring down this 2 here. 4 into 32 is going to be 8 times 4 is 32. We have a remainder of 0. So you can see here that y then does make sense to be equal to 9 and 92 hundredths. That would be the solution to this equation. All right, let's check out another example here. In this particular equation for number 3, we have 2 and 8/10 multiplied by some unknown number, m, is going to be equal to 26 and 4 hundredths. All right, so here are some potential values that m could be equal to. Let's see which one maybe we could try and start with here. We could just go left to right, but we could also jump around a little bit as well. Now, real quick, if you are just doing some quick estimating, if you take this answer choice of 10.1 and you substitute it in here for m, if you take 2.8 or 2 and 8/10 and you multiply by 10, that's already 28. So if you take this 2.8 and you multiply it by 10.1, that's actually going to be more than 28, which is not what we're looking for here. So that being said, we actually know that 10.1 can't be right and 11.5 can't be right either. Okay, so I guess really the question is it going to be either this 5.6 or this 9.3? Which one makes more sense here? Now, this 2.8 is really close to 3 if you round up, and this 9.3 rounds down to 9, so 3 times 9 is 27. That is pretty close here. This 5.6 rounds to a 6, I guess, right? And then this rounds up to a 3, so 3 times 6 would be 18. I don't think that's going to make sense either, and that's if you round them both up and it's still too small. So I think 5.6 also doesn't make sense. I think that based on that, we know 9.3 probably makes the most sense here. And we can confirm this by just going ahead and multiplying just to double check. So if we take this 9.3 and multiply that by 2.8, well, 3 times 8 is going to be 24, carry the 2. 9 times 8 is 72, plus the 2 is going to be 74. Put a placeholder here. 2 times 3 is going to be 6, 2 times 9 is 18. And if you add these two together, we're going to get 4 with 0, add a 1. That's going to be a 6, and add a 1, that's going to be 2. So we're really looking at 26 and 4/10, which I think is what we were looking for. So we do know here that m is equal to this 9 and 3/10. That is the solution. All right, cool. Let's check out number 4. For number 4, we have this equation, some unknown number n. If you go ahead and divide it by 7, we end up with 8.4. So which one of these 4 numbers, if you divide it by 7, do we end up with 8.4? Well, let's see here. If we go ahead and check out each of these, if we do some rounding here, this number here, 48.8, is pretty close to 49, right? And if we do 49 divided by 7, that's going to be 7, and that's going to be too low. So that's not going to work here, right? Maybe if we went a little bit higher, we could get the number that we're looking for here. So let's see, 53.8 is pretty close to 54, but 54 divided by 7 doesn't come out quite nice here, so it's kind of hard to say right away. So maybe we could go ahead and just do some division. So we take this 53.8 and divide this by 7. That's going to be, let's see, 7. I don't think it goes in 8 times, right? So 7 times 7 is 49. That's as close as we can get. But notice here that we're looking for 8 point something, right? And that we are starting off with 7 point something. So you don't have to finish the problem. We already know this is going to be too small. We need something bigger. What about this 58 and 8/10? If we take the 58 and 8/10 and try dividing that by 7, let's see, 7 goes into 58 8 times. 8 times 7 is 56, so a remainder of 2. Bring down this 8, put the decimal up here. 7 into 28 is going to be 4 times. 4 times 7 is 28. You see we have a remainder of 0. So we do get this 8.4, which is matching our value on the right side of the equation. So we actually know that this 58 and 8/10 is our solution. And so we can say that n is equal to 58 and 8/10. That would be the solution to this equation. All right, let's check out questions 5 through 8. This time we're going to go ahead and solve each of these equations. Specifically, we're going to use an inverse operation, and then we'll use the identity property of multiplication. And then let's go ahead and also check our solution to make sure it makes sense. All right, so number 5, let's go ahead and just write the equation down first. So we have 6/10 multiplied by some unknown value x is equal to 5 and 82 hundredths. So what's the operation here? This is 6/10 multiplied by x, because 6/10 is a coefficient. The inverse operation here is going to be dividing by the 0.6, since the inverse for multiplication is division. So let's divide both sides by 6/10 here. Now, what is 6/10 divided by 6/10? 6/10 divided by 6/10 is just going to be 1, so we're going to have 1x is equal to, and on the right side of the equation, we have to go ahead and divide these. Now, keep in mind that dividing by decimals is a little bit more frustrating to do, so we can just go ahead and multiply both of these values by 10, and we can just solve that division problem instead, right? So we can go ahead and take this 58.2, or 58 and 2/10, and divide this by 6 wholes, right? Both these values are 10 times bigger, so the answer to this would be the same as what we see in the original problem there. So 6 into 58, let's go 9. 9 times 6 is 54. The remainder here is going to be 4. And this 2 is going to come on down, bring the decimal straight up. 6 into 42 is 7 times. 6 times 7 is 42. We have a remainder here of 0. So we know this is going to end up being 9 and 7/10. So we can say that x is equal to 9 7/10. That's what we believe is the answer here. Okay, let's go ahead and check this to see if it's true. To check it, we would take this solution we found and substitute it in right over here. And we basically multiply 6/10 by 9 7/10 and see if it equals this 5.82 or 5 8/10. So let's go ahead and take this 9 7/10. Let's multiply that by 6/10 and see if this checks out. Well, 7 times 6 is 42, carry the 4. And then 6 times 9 is going to be 54, plus the 4 is going to be 58. So we have 582. We need 2 decimal places since we have 2 decimal places in our factors of what we're multiplying. This does equal this 5 82/100ths, so this checks out here. Now the inverse operation that we used in this particular problem was division. We divided both sides by 0.6 or 6/10. The identity property of multiplication is essentially saying here that we have this 1x because we said 6/10 divided by 6/10 is really just 1. And then using the identity property, 1 times any value is just that value. So we don't have to write the 1. So we can say x is equal to that 9 7/10. All right, let's try another one. For number 6, we have this equation. We have 5/6 multiplied by some unknown value, which is y, is equal to 2 1/2. Okay, cool. So let's see here. We can go ahead and divide both sides. Since this 5/6 is being multiplied by y, the inverse operation here is going to be dividing both sides by 5/6. Okay, so I'm going to write divide both sides by 5/6. Now, what's 5/6 divided by 5/6? Well, 5/6 divided by 5/6 is just going to be 1. So we're really looking at 1y is equal to. And what about the right side? How do you solve this? Well, 2 1/2 here is the same thing as 5 halves. So if you turn that into an improper fraction, it's just 5 over 2. And if you go ahead and divide here, we're going to divide by this 5/6 that we have on the bottom. So we can divide that by 5 over 6. Now, if you rewrite this, this is going to be 5 over 2 multiplied by 6 over 5. And notice here that this is just going to be 30 over 10. And that simplifies down to just being 3. So we can say 1y is equal to 3 because it turns out that this 2 1/2 divided by 5/6 is 3. And that just means that this 5/6 fits into 2 1/2 3 times. Using the identity property, you don't need to write this 1 in front of y because 1 times y is just going to be y. So you can say y is equal to positive 3 here. That would be our solution. Now, what if you want to check it? You take this 3 and you substitute it in right here, and we check what is 5/6 multiplied by 3. So let's take the 5/6, let's multiply it by 3. 3 is just 3 over 1. So 5 times 3 is 15, 6 times 1 is going to be 6. And then let's see, you can divide these both by 3 on top and bottom. If you do that, you're going to get 5 over 2. And 5 over 2 is the same thing as 2 1/2. So you can see here that this does check out because this 2 1/2 over here matches the 2 1/2 over here. For number 7, we have this equation 8 48/100ths is equal to 1 6/10 multiplied by some unknown value x. Don't be afraid of the fact that our variable's on the right side this time. It doesn't matter. We can solve it the same way. So 8 48/100ths is equal to 1 6/10 multiplied by x. Now, if the operation here is multiplication because we have this coefficient here, then what's the inverse operation? Well, the inverse operation is division. I'm going to use a fraction bar to show that. We're going to divide both sides by 1 6/10. Now, what's 1 6/10 divided by 1 6/10 on the right side? Well, that's just going to equal 1. So we can go ahead and write that this is going to be equal to 1x on the right side of the equation. Now, what about the left side? We have 8 48/100ths divided by 1 6/10. Dividing by decimal, as we said earlier, is a little bit more frustrating or difficult to do. So we can actually just multiply both of these values by 10 and slide the decimals to the right one place because dividing by 16 is a little bit easier to do. So let's go ahead and take this 884 8/10. If you move it over and make it 10 times bigger, and let's divide this by 16. So 16 times, let's go with 5. I think 5 is going to get us 80. That's as close as we can get. And our remainder here is 4. Now 16 into 48 is going to be 3 times. 3 times 16 is 48. the remainder here is 0. So it turns out here that our answer to 8 and 48/100 divided by 1 and 6/10 is going to be 5 and 3/10. So we can turn this around and just say x is equal to 5 and 3/10. This would be our solution. Okay, if we want to go ahead and check this, let's take this 5 and 3/10 and substitute it in for x here. So what's 1.6 multiplied by 5.3? We're going to hope it's 8.48. So let's take the 1 and 6/10. Let's multiply that by 5 and 3/10 and check to see what's going to happen here. 6 times 3 is 18. Carry the 1. 3 times 1 is 3 plus 1 is 4. We need a placeholder here. 5 times 6 is going to be 30. Put the 0, carry the 3. 5 times 1 is 5, plus the 3 is going to be 8. And if you go ahead and add these two rows together, we're going to get 8, and then 4, and then 8. Let's put a decimal in here. So we have 8 and 48/100, which matches what we were looking for over here on the left side of the equation. So that checks out. All right, one more of these types of problems. We have this equation 2 and 1/4 is equal to 2/3 multiplied by some number y. Let's go ahead and just rewrite this equation real quick. So 2 and 1/4 is equal to 2/3 multiplied by some unknown number y. So if we know that this is the operation of multiplication, what's the inverse? Well, the inverse would be division. So let's go ahead and divide both sides by 2/3. You can use a fraction bar to show that division. And on the right side, what's 2/3 divided by 2/3? Well, that's just going to be equal to 1. So we can go ahead and say this is equal to 1y. And then what about the left side of the equation? On the left side, we have 2 and 1/4 divided by 2/3. So this 2 and 1/4 we can turn into an improper fraction. That is just going to end up being 9/4. And we're going to divide that by the denominator. The denominator here is just 2/3. So let's keep this as 2/3 for a moment. Now, if you rewrite this as a multiplication problem, this is going to be 9/4 multiplied by 3/2. And if you go ahead and do that, we're going to get 27/8. And for the purposes of this problem, I'm just going to leave that as 27/8 for now. And you can leave it like this or write it as a mixed number. It doesn't really matter. If you want to write a mixed number, you can say it's going to be 3. 3 times 8 is 24. That's 3 away from 27, so it's 3 and 3/8. It's perfectly fine. And this would be another way you could write our answer, 3 and 3/8, right? Now, how could you check this? Well, you take this 3 and 3/8 and you substitute it in for y, and you multiply it by 2/3, and we hope to get 2 and 1/4. So if we know we're going to be multiplying here, let's just use the improper fraction version. Let's use this 27/8 here. So let's take the 2/3 and multiply it by 27/8. Right, which is the same thing as 3 and 3/8, and let's see what we're going to get here. So 2 times 27 is going to be 54, then 3 times 8 is going to be 24. You can divide top and bottom here by 6. Let's divide by 6 and divide by 6, see what that helps us do. I think that's going to bring us down to being 9/4. And that's actually pretty promising because as a mixed number, 9/4 is just 2 and 1/4. So you can see this 2 and 1/4 over here actually does match the 2 and 1/4 that we had over here. So this does make sense. All right, let's try a few different application problems now. For 9 and 10, let's go ahead and apply our understanding to some problems that are not so straightforward, that maybe you have to kind of think about how to set it up and put the right pieces in the right spots before we can start solving. So we're going to go ahead and set up a one-step equation. Once we set up our one-step equation, we're going to go ahead and see if we can also show some detailed and logical work and write a conclusive statement since it's a word problem. All right, so Jackson bought 4 of the same pencil sharpener, spending a total of $95.40. How much did one pencil sharpener cost? Well, we have the number of items. Well, it looks like Jackson's buying 4 of these, so 4 of these. Multiplied by, because we're buying 4 of the same thing, the price of one item here, we actually don't know what that is here, so I'm actually going to use P to represent the price of one item. And this is going to be equal to, well, if he buys 4 of the same item, how much is that going to cost? Well, we know the total here is $95.48, so $95.48. So what would the equation be? Well, 4 times P is really just 4P. So 4 pencil sharpeners is going to cost $95.48. So this is our one-step equation. What if we want to solve it to find out how much one pencil sharpener costs? Well, the inverse operation for multiplication is going to be division. So what's 4 divided by 4? 4 divided by 4 is just going to be 1. So we're going to be left with 1p, or one of these pencil sharpeners, the cost of it. And we have to figure out what this price divided by 4 is going to be. So 95.48. If we divide that by 4, it's going to go in 2 times. 2 times 4 is 8, where remainder is 1. Bring down this 5 here. So 4 times 3 is 12. The remainder here is going to be 3. Put a decimal up here and bring down this 4. 4 into 34, let's go with 8. 8 times 4 is 32. The remainder here is 2. Let's bring down this 8. And then 4 into 28 is going to be 7. 7 times 4 is 28. And so this would end up being a remainder of 0. So if we take this price and we divide it by 4 to find out the price of each of these pencil sharpeners, that's going to be $23.87. So we're going to have 23.87 hundredths here. So using the identity property, we can just say P, or the price of one item, is going to be $23.87. And so for our conclusion, we can say one pencil sharpener is going to cost $23.87. Here was our one-step equation. In this step here, we used the inverse operation of division. We divided both sides by 4. Getting 1 here is using that multiplicative inverse property. And then when we got rid of the 1 and turned it into just saying P equals, that's using the identity property of multiplication. All right, cool. Let's try one more example here. In number 10, Peyton and 3 of her friends went out to eat and decided to split the bill evenly. They each ended up paying $16.87. What was the total bill cost here? So the question says, what is the total bill? So for the total bill, we don't know what it is. Let's go ahead and just maybe put T for total. The total bill is, should we multiply the cost of all the food by something, or is it being split evenly amongst people? Well, if it's being split, hopefully that makes sense, where that means we're actually going to divide all of that money between a few people. Now, how many people are we talking about? Well, it looks like Peyton is going with 3 friends. So Peyton plus her 3 friends, that's going to be a total of 4 people. And what do we know about this? Well, if you split it 4 ways, do we know how much each person is going to be paying? It looks like each person is paying $16.87. That's for one person. So see if this makes sense. The total bill, if it's split 4 ways or divided and cut into 4 equal pieces, it's $16.87 per person. So how could you write this equation? You could say T over 4, or T divided by 4, is equal to 1687. So how would you solve this one-step equation? Well, we can see that our operation is division, so the inverse operation is going to be multiplication. So let's go ahead and multiply this left side and right side both by 4. So if you multiply the left side by 4, you can also just write that as 4 over 1. But on the right side, I'm just going to write times 4, because that's not a fraction on the right side. We don't need it. On the left side here, you can see here, if you multiply, what's 4 times t? 4 times t would just be 4t. And what's 1 times 4? 1 times 4 is just going to be 4, so we're going to get 4t over 4. Now what's going to happen with these 4s is these 4s are going to cancel out to make 1, because what's 4 divided by 4? 4 divided by 4 is just going to be 1, so we're going to end up here with 1t. Okay, now what about the right side of this equation? 1687 times 4. If we take the 1687, that's how much one person paid, and you multiply by 4 to figure out what they paid altogether. 7 times 4 is 28, carry the 2. 8 times 4 is 32, plus the 2 is 34, carry the 3. 6 times 4 is 24, plus the 3 is 27, carry the 2. 4 times 1 is 4, plus the 2 is going to be 6, and we need 2 decimal places, so I think we're looking at 67.48. So the 1t is really just t equals, or the total bill is going to be $67.48. So we can say that the total bill for Peyton and her 3 friends was going to be $67.48. You can see that we started off with our one-step equation here. That's right over here. When we went ahead and multiplied both sides by 4, that's using the multiplication property of equality. Then basically we ended up with getting 1 over here, just because you can see 4 divided by 4 does equal 1. And then you can see we got rid of the 1 by using the identity property of multiplication. in summary, this number that we got here is just telling us how much the food was altogether for Peyton and her friends. All right, so there you have 10 different practice problems where we went ahead and applied our understanding of solving equations. Specifically in this set of practice problems, we dealt with equations that had two different operations. Some of them had multiplication and some had division. When we saw ones with multiplication, we used the inverse operation of division. And when we saw ones with the operation of division, we used the inverse operation of multiplication. Now, if you found the video helpful, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.